All right, hello everyone. Welcome to my channel. I do educational videos on many different subjects, but we've been locked in here on the reciprocal system of theory. This is the 163rd video that we've done on this, and the reciprocal system of theory was first derived by Dewey B. Larson back in the 20th century. He died back in 1990, but before he died, he put out a dozen or more books and several dozen articles on his reciprocal system. The basic idea is that this here is a universe of motion. It's not a universe of matter, not a universe of energy, but a universe of motion. The fundamental thing, most fundamental thing in the universe is motion. And you can get that out of E equals mc squared, Einstein's equation. Energy equals matter times the speed of light squared. If energy can be converted into matter and vice versa, that means neither one of them can be the most fundamental thing. In fact, the most fundamental thing is the c squared part, the speed of light squared. And Larson goes to show that if the universe is made out of motion, other people have come up with that in the past, but Larson extended that idea by defining motion as the relationship between space and time. So what that implies is that space and time are reciprocals of each other. When you have a relationship, you're talking about a fraction. Motion is a fraction with either time or space as the numerator and either space or time as the denominator. Also, space and time both have their coordinate aspects, meaning that they both have three or more dimensions. And they must also have an aspect where they both are progressing. Larson calls that clock space and clock time. Time is always moving forward. It's always getting later and later and later. And space is always progressing or flowing. It's always getting farther and farther and farther apart, which was originally detected by the Hubble telescope back in the 1920s. All of the distant galaxies are moving away from each other. Time and space also both come in only discrete units. And even though those units are small, they appear to be continuous, but they are not. They are discrete. They come in chunks only. And 1 unit of time, 1 unit of space in 1 unit of time is the speed of light. And so there we're back to the speed of light as the most fundamental thing. The speed of light is 1 over 1 equals 1. And 1, that is what Larson calls unit speed. And he calls it the progression of the natural reference system, is the motion at the speed of light in all directions. Larson calls that a scalar motion, a motion that has a magnitude, but it has no direction, which you can visualize by taking a balloon and putting a bunch of dots on it with a magic marker. When you blow up the balloon, all the dots move away from each other. When you suck in the balloon, all the dots move toward each other. But there is no particular direction involved. So that is a scalar motion. And so in Larson's system, all measurements are taken from the natural reference system, or this unit speed in all directions outward. And so that is a big difference from legacy science, which makes all their measurements from 0. In the reciprocal system, all measurements are made from 1. In fact, in Einstein's system, the speed of light is actually, he says that the speed of light is the maximum speed of the universe. In Larson's system, the speed of light is the midpoint, or even the origin of the universe. And There's a half of the universe that moves faster than the speed of light and a half of the universe that moves slower than the speed of light. Those are called the cosmic sector and the material sector, respectively. Okay, now that is just a brief intro, but what we're doing today is we're going through chapter 8 of his book that is called Nothing But Motion. And Nothing But Motion came out in 1979, and it is about mostly physics. It is the first volume of his 3-volume work called The Structure of the Physical Universe, and that also includes Basic Properties of Matter, which is primarily on chemistry, and Universe of Motion, which is on astronomy. So we will be taking a look at those things later, and we will also look at some of the other authors who have written things about the reciprocal system, probably even including me. I haven't written much about the reciprocal system, but one article on astronomy. And okay, we're in chapter 8, which is called Motion in Time. And when you have motion in time, basically you're talking about a motion that is faster than the speed of light. So he's talking about these areas in the universe that we don't really know too much about. Einstein didn't know anything about them. That's why he said that the speed of light is the maximum speed of the universe. He didn't know about the half of the universe that's moving moving faster than the speed of light. I think I might have said the speed of light is the maximum speed, is what Einstein says. Now, because of the reciprocal relationship between space and time, all you have to do is invert to get the if you know about the material sector, you can understand the cosmic sector simply by inverting the roles of space and time. In the material sector, most of the relationships are space over time relationships. In the cosmic sector, most of the relationships are time over space relationships. Okay, we're going to start here. He was just talking about how the Lorentz contractions or the Lorentz equations fit into his theory, as does the Michelson-Morley experiment. And he's really saying that most of what science has already come up with fits into his system. There's only disagreement really at the margins, the very fast, the very slow, the very large, and the very small. And so he'll probably be going on with that idea here. Most of the other well-established relationships of physical science are similarly incorporated into the new system of theory, the reciprocal system of theory, with or without minor modifications as the development of the theoretical structure proceeds. Not because of the weight of observational evidence supporting these relations, or because anyone happens to approve of them, or because they have previously been accepted by the scientific world, but because the conclusions expressed by these relations are the same conclusions that are reached by the development of the new theoretical system. After such a relation has thus been taken into the system, it is of course part of the system, and can be used in the same manner as any other part of the theoretical structure. The existence of speeds greater than unity, the speed of light, the speeds that result in change of position in time, conflicts with current scientific opinion, which accepts Einstein's conclusion that the speed of light is an absolute limit that cannot be exceeded. Our development shows, however, that at one point where Einstein had to make an arbitrary choice between alternatives, he made the wrong choice. And the speed limitation was introduced through this error. It does not exist in fact. Like the special theory of relativity, the theory from which the speed limitation is derived is an attempt to provide an explanation for an empirical observation. According to Newton's second law of motion, which can be expressed as A equals F over m, if a constant force is applied to the acceleration of a constant mass, it should produce an acceleration that is also constant. But if a series of experiments showed that where a presumably constant electrical force is applied to a light particle, such as an electron, in such a manner that very high speeds are produced, the acceleration does not remain constant, but decreases at a rate which indicates that it would reach zero at the speed of light. The true relation, according to the experimental results, is not Newton's law, A equals F over m, but A equals negative the square root of the quantity 1 minus V over C, F over m. In the system of notation used in this work, which utilizes natural rather than arbitrary units of measurement, the speed of light, designated as c in current practice, is unity, and the variable speed or velocity v is expressed in terms of this natural unit. On this basis, the empirically derived equation becomes A equals F over m. There is nothing in the data derived from experiment to tell us the meaning of the term 1 minus v to the second power. In this expression, whether the force increases at higher speeds or the mass increases, or whether the velocity term represents the effect of some factor not related to either force or mass, Einstein apparently considered only the first two of these alternatives. While it is difficult to reconstruct the pattern of his thinking, it appears that he assumed that the effective force would decrease only if the electric charges that produce the force decreased in magnitude. Since all electric charges are alike, so far as we know, whereas the primary mass concentrations seem to be extremely variable, he chose the mass alternative as being the most likely, and assumed for purposes of his theory that the mass increases with the velocity at the rate indicated by the experiments. On this basis, the mass becomes infinite at the speed of light. The results obtained from development of the consequences of the postulates of the reciprocal system now show that Einstein guessed wrong. The new information developed theoretically, which we will discuss later in detail, reveals that an electric charge is inherently incapable of producing a speed in excess of unity, and that the decrease in the acceleration at high speeds is actually due to a decrease in the force exerted by the charges, not to any change in the magnitude of either the mass or the charge. As explained earlier, force is merely a concept by which we visualize the resultant of oppositely directed motions as a conflict of tendencies to cause motion rather than as a conflict of the motions themselves. This method of approach facilitates mathematical treatment of the subject and is unquestionably a convenience. But whenever a physical situation is represented by some derived concept of this kind, there is always a hazard that the correspondence may not be complete, and that the conclusions reached through the medium of the derived concept may therefore be in error. This is what happened in the case we are now considering. If the assumption that a force applied to the acceleration of a mass remains constant in the absence of any external influences is viewed only from the standpoint of the force concept, it appears entirely logical. It seems quite reasonable that a tendency to cause motion would remain constant unless subjected to some kind of a modifier. But when we look at the situation in its true light, as a combination of motions rather than through the medium of an artificial representation by means of the force concept, it is immediately apparent that there is no such thing as a constant force. Any force must decrease as the speed of the motion from which it originates is approached. The progression of the natural reference system, for instance, is motion at unit speed. It therefore exerts unit force. If the force, that is, the effect of the progression, is applied to overcoming a resistance to motion, the inertia of a mass, it will ultimately bring the mass up to the speed of the progression itself, unit speed. But a tendency to impart unit speed to an object that is already moving at high speed is not equivalent to a tendency to impart unit speed to a body at rest. In the limiting condition where an object is already moving at unit speed, the force due to the progression of the reference system has no effect at all, and its magnitude is zero. Thus, the full effect of any force is attained only when the force is exerted on a body at rest, and the effective component in application to an object in motion is a function of the difference between the speed of that object and the speed that manifests itself as a force. The specific form of the mathematical function, which is a tilde rather than merely 1 minus v, is related to some of the properties of compound motions that will be discussed later. Ordinary terrestrial speeds are so low that the corresponding reduction in the effective force is negligible. And at these speeds, forces can be considered constant. As the speed of the moving object increases, the effective force decreases, approaching a limit of zero when the object is moving at the speed corresponding to the applied force, unity in the case of the progression of the natural reference system. As we will find in a later stage of the development, an electric charge is inherently a motion at unit speed, like the gravitational motion, and the progression of the natural reference system, and it, too, exerts zero force on an object moving at unit speed. As an analogy, we may consider a case of a container full of water, the case of a container full of water, which is started spinning rapidly. The motion of the container walls exerts a force tending to give the liquid a rotational motion. And under the influence of this force, the water gradually acquires a rotational speed. But as that speed approaches the speed of the container, the effect of the constant force drops off. And the container speed continues, and the container speed constitutes a limit beyond which the water speed cannot be raised by this means. The force vanishes, we may say. But the fact that we cannot accelerate the liquid any farther by this means does not bar us from giving it a higher speed in some other way. The limitation is on the capability of the process, not on the speed at which the water can rotate. The mathematics of the equation of motion applicable to the acceleration phenomenon remain the same in the reciprocal system as in Einstein's theory. It makes no difference mathematically whether the mass is increased by a given amount or the effective force is decreased by the same amount. The effect on the observed quantity, the acceleration, is identical. The wealth of experimental evidence that demonstrates the validity of these mathematics therefore confirms the results derived from the reciprocal system to exactly the same degree that it confirms Einstein's theory. All that this evidence does is in either case is to show that the theory is mathematically correct. But mathematical Mathematical validity is only one of the requirements that a theory must meet in order to be a correct representation of the physical facts. It must also be conceptually valid. That is, the meaning attached to the mathematical terms and relations must be correct. One of the significant aspects of Einstein's theory of acceleration at high speeds is that it explains nothing. It merely makes assertions. Einstein gives us an ex cathedra pronouncement to the effect that the velocity terms represents an increase in the mass without any attempt at an explanation as to why the mass increases with the velocity. Why this hypothetical mass increment does not alter the structure of the moving atom or particle as any other mass increment does. Why the velocity term has this particular mathematical form, or why there should be a speed limitation of any kind. Of course, this lack of a conceptual background is a general characteristic of the basic theories of present-day physics, the free inventions of the human mind, as Einstein described them. And the theory of mass increase is not unusual in this respect. But the arbitrary character of the theory contrasts sharply with the full explanation provided by the reciprocal system. This new system of theory produces simple and logical answers for all questions, similar to those enumerated above, that arise in connection with the explanation that it supplies. Furthermore, one of these is, in any respect, ad hoc. All are derived entirely by education from the assumptions. I think that word should actually be deduction instead of education. All are derived entirely by deduction from the assumptions as to the nature of space and time that constitutes the basic premises of the new theoretical system. Okay, that'll be wrapping it up for today, and we will talk to you tomorrow. Thanks for tuning in.